Matter, the building blocks of our world. It's the essence of everything around us, the very substance that forms the foundation of our existence. Everything we see, touch, and interact with is made of matter. From the simplest objects we use daily to the most complex structures, matter is omnipresent. It's the fundamental stuff that fills our universe, from the smallest grain of sand to the largest star. Every particle, every celestial body is a testament to the diversity and complexity of matter. Ancient philosophers pondered its nature, proposing elements like earth, air, fire, and water. These early theories laid the groundwork for our modern understanding. Today, we understand matter as anything that occupies space and possesses mass. This definition, though simple, encompasses a vast array of phenomena. This simple definition unlocks a universe of complexity, revealing the building blocks of our existence. From the tiniest subatomic particles to the grandest galaxies, matter is everywhere. Modern science classifies matter in a more detailed way. Through meticulous study and experimentation, we've identified and categorized the elements that make up our world. We now know of elements like hydrogen, oxygen, and carbon. These fundamental elements are the building blocks of countless compounds and materials. These elements combine to form an astounding variety of compounds, from the water we drink to the complex molecules that make up our bodies. The diversity of matter is truly astonishing. The study of matter is a journey into the heart of reality itself. By exploring the nature of matter, we gain insights into the very fabric of the universe. Understanding matter is essential to comprehending the world around us. It allows us to make sense of the physical properties and behaviors of the objects we encounter. It allows us to explain the properties of objects, from their weight and texture to their ability to conduct heat or electricity. These properties are crucial for countless applications in science and technology. By delving into the nature of matter, we unlock the secrets of the cosmos and our place within it. The more we learn, the more we realize how interconnected everything is. The universe is constantly evolving, with matter undergoing transformations on scales both grand and small. These changes drive the dynamic processes that shape our world. Stars are born from swirling clouds of gas and dust, their immense gravity fusing atoms and releasing energy. This stellar alchemy is a fundamental process in the universe. On Earth, life itself is a testament to the dynamic nature of matter, with organisms constantly exchanging materials with their environment. This continuous exchange is vital for sustaining life. Matter exists in different states, each with unique characteristics determined by the arrangement and motion of its particles. These states are not just abstract concepts, but are fundamental to understanding the physical world around us. The three most familiar states are solid, liquid, and gas. Each of these states can be observed in our daily lives, from the ice in our drinks to the steam rising from a hot cup of coffee. In solids, particles are tightly packed, vibrating in place. This close arrangement gives solids their definite shape and volume. Liquids have particles that are close together but can move around, giving them a fluid shape. This allows liquids to flow and take the shape of their container while maintaining a constant volume. Gases have particles that are far apart and move freely, expanding to fill any container. This freedom of movement means gases have neither a fixed shape nor a fixed volume. Imagine a group of people dancing. In a solid, they would be packed tightly together, swaying slightly but staying in one place. This is similar to how particles in a solid are restricted in their movement. In a liquid, they could move around more freely, flowing across the dance floor. This fluidity is akin to how particles in a liquid can slide past one another. In a gas, they would be scattered widely, moving independently of one another. This independence mirrors the behavior of gas particles, which move rapidly and are widely spaced. The state of matter is influenced by factors like temperature and pressure. These factors can cause matter to change from one state to another, a process known as a phase transition. Heating a substance increases the kinetic energy of its particles, causing them to move faster. This increased movement can lead to a change in state, such as ice melting into water. Cooling a substance has the opposite effect. It decreases the kinetic energy of the particles, causing them to slow down and potentially change state, like water freezing into ice. Changes in pressure can also force particles closer together or farther apart. This can result in a change of state, such as gas condensing into a liquid under high pressure. Understanding the states of matter allows us to explain many everyday phenomena. For instance, the melting of ice into water is a common example of a solid turning into a liquid. Why does ice melt into water? Because heat energy overcomes the forces holding the water molecules in a rigid structure. This process is a clear demonstration of how energy affects the state of matter. Why does water boil and turn into steam? Because the water molecules gain enough energy to escape from the liquid phase and become a gas. This transformation is a vivid example of how energy can drive changes in the state of matter. Evaporation is the process by which a liquid changes into a gas at a temperature below its boiling point. This fascinating transformation is a key part of the water cycle and plays a crucial role in various natural and human-made processes. It occurs because some molecules at the surface of a liquid have enough energy to break free from the attractive forces of their neighbors and escape into the air as vapor. This escape is a dynamic dance of energy and motion. As these higher energy molecules escape, the average kinetic energy of the remaining liquid molecules decreases, resulting in a cooling effect. This cooling effect is why we feel cooler when we sweat on a hot day. Think of a puddle of water drying up on a sunny day. The sun's energy heats the water, giving some molecules enough energy to escape into the air. The sun's energy provides some water molecules with enough energy to overcome the attractive forces holding them in the liquid. This process is a beautiful example of nature's efficiency. These energized molecules escape into the air as water vapor, leaving behind a cooler puddle. This is why the remaining water feels cooler to the touch. This cooling effect of evaporation has many practical applications. From cooling our bodies to cooling our homes, evaporation is a natural and efficient cooling mechanism. When we sweat, the evaporation of perspiration from our skin helps to regulate our body temperature. This natural cooling system is essential for maintaining our health, especially during intense physical activity. We use evaporative coolers to cool homes and buildings in hot, dry climates. These devices mimic the natural process of evaporation to provide a cost-effective and energy-efficient cooling solution. The rapid evaporation of liquids like acetone and rubbing alcohol is why they feel cool to the touch. This rapid cooling effect is utilized in various medical and cosmetic applications. Evaporation is a continuous process that occurs at all temperatures. Whether it's a hot summer day or a cool winter morning, evaporation is always at work. The rate of evaporation depends on factors such as temperature, humidity, and wind speed. Understanding these factors can help us harness the power of evaporation more effectively. Higher temperatures, lower humidity, and higher wind speeds all increase the rate of evaporation. By manipulating these conditions, we can optimize evaporation for various practical uses.